I hope you've not forgotten that mode is just the highest occurring number. So mode is the highest occurring number in a data set. Now, for example, if I have 1, 2, 3, 5, 7, 2, 0, 1, 1, and I'm asked what is the mode in this set of data. Now, what number occurs more? Definitely 1. So my mode is 1. So mode equals to 1. It then means that it is very easy to find mode in an ungrouped data like this one. Now the question is, how do we calculate the mode of a grouped data? To explain this, let me just give us a brief example of a grouped data. So if I've got weight and say frequency, and let's say we have 51 to 55, we have 56 to 60, we have 61 to 65, and we have 66 to, let's say, 70, and we have, say, 3 to 1, 1. Now in this case we have a group data, and if I ask you to find a modal group or modal class, as the case may be, it's easy because it's the group that occurs more, and so you know that the modal group will be 51 to 55 because it occurs 3 times. But if I ask you to find the mode or the estimated mode, now it becomes more difficult because from 51 to 55 we have so many numbers. For example, we have, if we are talking about whole numbers, we have 52, we have 53, we have 54, we have 55, we even have 51. So the question is, among these 5 numbers, what is the mode? How do we get the mode? And that is why finding the mode for group data is a bit advanced than finding the mode for ungrouped data. Now let's take the formula to find the estimated mode for group data. Now the formula for mode equals to LM plus FM minus F minus 1. These are subscripts all over FM minus F minus 1. Then we've got plus FM minus FM plus 1. Now this over covers everything times the width. Now this here is the formula for mode. Now you may be wondering, what is LM, FM, FM minus 1, etc. So LM is the lower class boundary, of the modal class, or group. Then FM is the frequency of the modal group. Then we have FM minus 1 is the frequency of the group or class before the modal group. Then we have FM plus 1, that's the frequency of the group after the modal group. What else? We have W. W is the width of the data set. Does this make sense? So I think we know LM, FM, FM minus 1, FM plus 1, and W. Now if you look at it very well, FM is the frequency of the modal class. FM minus 1 is the frequency of the class before the modal class, while FM plus 1 is the frequency of the class after the modal class. Does this make sense? And then W is the width. And I think I made a mistake in lower, so it should be lower, not lower. Do you understand this? Now I want to try to explain this formula so that you remember it. Let's take an example and let's see if we can explain the formula. So I've got this question: calculate the mode of the data set below. We have weight and frequency. So the first thing we want to do is to turn this into a vertical table. So let's try to solve this. So we've got weight, and then we have frequency. So we have 51 to 55. We have 56 to 60. We have 61 to 65. We have 66 to 70. And then we have 71 to 75. Frequency, we have 3, 2, 5, 2, 1. Does this make sense? Now don't forget the formula for mode. Let me write it somewhere here. Mode equals to Lm plus Fm minus Fm minus 1 all over Fm minus Fm minus 1 plus Fm minus Fm plus 1 times the width. I hope you understand this. Alright, so I said I want to explain this formula so you can kind of get it. Now there's another method we can use to calculate the mode, and that is plotting the histogram. And let's try to do a kind of rough stuff here so that you can understand this formula, or the way I understand this formula. Now to draw the histogram, we need the class boundary. So let's have the class boundary here. Now to get the class boundary, all we need to do is to subtract 0.5 from the first number and then add 0.5 to the second. Do you understand? So if I subtract 0.5 from 51, I should have 50.5. So I have 50.5 to 55.5 because I add 0.5 to 55. I do the same thing to this one, so I should be having 55.5 to 60.5. I do the same to this one, I should be having 60.5 to 65.5. Then I should be having 65.5 to 70.5. Then lastly 70.5 to 75.5. Now that we've done this, we can now plot the histogram. Now remember, all I want to do is to help you make sense of this mode formula. Now let's have a rough diagram of this histogram. So this part would be frequency, and then this part would be the class boundary. So frequency is from 1 to 5, so I can have 1, 2, 3, 4, and 5. Then for the class boundary, I have 50.5. Then I have 55.5. Then we've got 60.5. Then we have 65.5. Then we've got 70.5. And then we have 75.5. Now let's try to plot. So we can say that the first one is 3. Frequency is 3, so we have, sorry, this is just something rough. Then the next one is, the frequency is 2, so we should have, the next one, frequency is 5, so we have 5. The next, the frequency is 2, so I've got 2. And then the last, the frequency is 1, so we've got 1. Now if you look, it's obvious that the modal group is still this longest bar. Sure. But how do we find the mode itself, the real mode? Now the method to finding mode using the histogram is like this. Now watch carefully. So I'm going to join this part of the highest bar to the bar beside it. Can you see? I do that to the other part, this part to the bar after it. Can you see? Now remember, this is just something rough. Now if you look carefully, our mode will now be this part they meet. We are going to trace it down to the graph. And this will be the mode. Does this make sense? Now, okay, so now let's try to figure out how this relates to the formula of mode. Now remember, this FM is the frequency of the modal group. So that is like 5, the frequency of the modal group. 5, let me use another color. Then F minus 1 is like the frequency of the group before the modal group. So it's like this one, 2, this part here, the frequency of this group here. And then we have Fm plus 1 is like the frequency of this group here. Does that make sense? Now the width is how fat this bar is. Now by multiplying this part with the width, it helps us to know where the line is. This line here. Exactly. Does that make sense? Look again. W is how fat the bar is. Then this part multiplied by W help us to know the exact place. Does that make sense? Now to finally read the mode, we have to plus the lower class boundary, which is this 60.5 here. Does that make sense? Now if I try to calculate the mode for this one, just a rough estimate, I know Fm, which is the frequency of the modal class, to be the frequency of this long bar, that is 5. Fm minus 1 is the frequency of the bar before it, so that is 2. So we have 5 minus 2 all over, so we'll still have 5 minus 2 here, plus Fm is what? 5 minus Fm plus 1 is the frequency of the bar after it. In this case, the frequency is still 2, so we have 5 minus 2. 5 minus 2 is 3, so we have 3 over 5 minus 2 is 3, so we have 3 plus 3, that is 3 over 6, that will give us 1 over 2. Does that make sense? So this part here is 1 over 2. If I multiply by the width, how fat the width is, how fat would be 65.5 minus 60.5, and that should give us 5, so times 5. So it means that to find the mode here is just like half of this bar. So dividing this bar into 2, we are going to get the mode. And this kind of makes sense if you consider that these two are on the same point, which means that from year to year be the same as from year to year. It then means that where they would meet would be the midpoint, the middle of this bar. So by multiplying this big stuff here by the width, we just know the exact place the middle line is, or the line is, and then adding it to the lower class boundary help us to now find the exact mode. I just hope that by illustrating this, you are able to see this formula in another new light and it makes some more sense to you. Now let's solve the question. Now remember, I told you the first thing to do is to turn the table above. You turn this table here to a vertical table as we have beneath here. Now the next thing you want to do is to write the formula. So let's write the formula here. So we know mode equals to lower class boundary of the modal group plus frequency of the modal group minus frequency of the group before it, all over frequency of the modal group minus frequency of the group before it, plus frequency of the modal group minus frequency of the group after it, times the width. Does this make sense? Now the first thing you want to find is what is even the modal group. And remember, the modal group is a group with the highest frequency, so 61 to 65. Does this make sense? Now what's the lower class boundary of the modal group? Lm equals to, so we have 61 minus 0.5. That should give us 60.5. Does that make sense? Now Fm is the frequency of the modal group. That should give us 5. Then Fm minus 1 is the frequency of the group before the modal group. So that should be 2. Does this make sense? Then we have Fm plus 1, the frequency of the group after the modal group. Then lastly, the width. Now to get the width, all we need to do is to say 61 minus 56. Does that make sense? It's still going to be the same thing as 56 minus 51, 66 minus 61, 71 minus 66. The width is always equal. Does that make sense? Another way you can get is to say 60 minus 55, 65 minus 60, 70 minus 65, 75 minus 70. So if you do any of that, we are going to get 5. For example, 70 minus 65 will give you 5. Also, 66 minus 61 will also give you 5. So the width is 5. So we need to slot all this into the formula. Now let's do that. So we're having mode equals to 60.5 plus FM is 5. So we have 5 minus FM minus 1 is 2. All over, we have FM is 5 minus FM minus 1 is 2. Then we've got plus FM is 5 minus FM plus 1 is 2. Now remember, this over covers everything times the width. The width is 5. Do you understand that? Now let's do this. Mode equals to 60.5 plus 5 minus 2 is 3. All over 5 minus 2 is 3 plus 5 minus 2 is 3. Does this make sense? Times 5. So we have mode equals to 60.5 plus 3 all over 3 plus 3 is 6 times 5. Does this make sense? We can have 3 here 1, 3 and 6 is 2. So if we do it by the side here, mode equals to 60.5 plus 1 over 2 times 5 over 1. So we have mode equals to 60.5 plus 1 times 5 is 5 all over 2 times 1 is 2. Can you see I finished doing this right hand side first before I would now add it to 60.5 so that you don't make a mistake. So we should be having mode equals to 60.5 plus 5 divided by 2, remainder 1. So if I add points here, 10 is 5. So 5 over 2 is 2.5. So we have 60.5 plus 2.5. Then mode equals to 60.5 plus 2.5 will give us 63. Now this is our mode. Do you understand? Now the most important thing is remembering this formula, because as long as you remember this formula, you will be able to solve it. Solving it will become very easy. So LM, lower class boundary of the modal class, plus FM, frequency of the modal class, minus the frequency of the class before it, all over frequency of the modal class minus the frequency of the class before it, plus frequency of the modal class minus the frequency of the class after it, times the width. And don't forget, it's not all over. The division sign does not cover the lower class boundary of the modal class. And also, to kind of remember it, don't forget this histogram we got. Remember, it's like this. So you are trying to say frequency of the modal class minus this, all over frequency of the modal class minus this, plus frequency of the modal class minus this, multiplied by how fat this bar is. I hope you understand this and you will not forget it.